In this module, we are going to look at combustion reactions. By the end of this module, you should be able to write and balance the equation for the combustion of a hydrocarbon compound. Just a reminder of what a hydrocarbon is. This is a type of organic compound. It contains hydrogen and carbon. We see that we can have branched chains, we can have straight chain compounds, ring structures, single, double, or triple bonds are all possible. Lots of different ways to attach these atoms to one another. And we're going to worry about what the combustion looks like for these substances. So when we have a combustion reaction, a hydrocarbon reacts with oxygen to produce CO2 and water. Now the actual balancing the equation, we'll go back to what we learned before about balancing. We know that combustion always means adding oxygen and forming CO2 and water. So let's look at an example of how we would write and balance the equation for the combustion of C3H8, which is also known as propane. So the first thing we want to do is we want to write our formula for our reactant C3H8. We know that because it's a combustion reaction, it's going to react with oxygen, and we're going to produce CO2 and water. And whenever we're dealing with combustions of a hydrocarbon, this is always the basic reactant and products that we're going to add to our hydrocarbon. Now what we have to look at is to balance the equation. So just as I did before, I'm going to make a list of the elements of each element in our compounds and our reactions, and I'm going to tally up the number that I have. So here I have 3 carbons, 8 hydrogens, and 2 oxygen atoms on the reactant side. On the product side, I have 1 carbon, I have 2 hydrogens, and I have 3 oxygens. Notice that I've got oxygens in 2 different places, so I have a 3 there for my oxygens. I'm going to start with my carbon because I have 3 carbons on the left and only 1 on the right, so I need to add a coefficient of 3 in front of CO2. When I do that, that changes to having 3 carbons, but it also changes the number of oxygen atoms. So now I have 6 plus 1, or 7 oxygen atoms. Next, I'm going to look at the hydrogen atoms and balance those, and I'm going to do that by adding a coefficient in front of water. So I have 8 hydrogens on the left and only 2 on the right, so I'm going to add a coefficient of 4 in front of water. When I do that, that gives me 8 of my hydrogens, but it also changes the number of oxygens. So I have 6 from my CO2 and I have 4 from the water, so that makes a total of 10 oxygens. And notice how each time I add a coefficient, I update my tally here so that I can keep track of what I have of each element. Now I see that my carbon is balanced, my hydrogens are balanced. The only thing that's unbalanced is my oxygens. I have 10 oxygen atoms on the right. I need 10 oxygen atoms on the left. Since I have O2, I can add a 5 as a coefficient. So now I have 10 oxygen atoms on the left. Before I do anything else, I'm going to go back and double check. 3 carbons, 8 hydrogens, 10 oxygens, and then 6 plus 4 for a total of 10 oxygens. So whenever you balance the equation, always make sure that you go back and check at the end to make sure everything is truly balanced. So let's look at an example where you determine the coefficient for O2 in the balanced equation for the combustion of C2H4. Remember that when I have a combustion, I'm always adding oxygen and producing CO2 and water. It's no different because I have a compound here with a double bond. So I have my C2H4 plus oxygen yields CO2 plus H2O. Just as I did before, I'm going to make a list of my elements, which frequently in combustion reactions is simply carbon, hydrogen, and oxygen. I have 2 carbons on the left, 4 hydrogens, and 2 oxygens on the left. On the right, I have 1 carbon, I have 2 hydrogens, and 3 oxygens. So I see that none of my elements are balanced. I'm going to start with the carbon. I'm going to add a coefficient of 2 there in front of CO2. That changes the number of carbons from 1 to 2, but it also changes the number of oxygens. I have 4 oxygens, plus the 1 more makes 5 oxygens. I now need to balance the number of hydrogens, so I'm going to add a 2 in front of the water molecule, so that now I have 4 hydrogens, but that also changes the number of oxygens, so I have 4 oxygens here and 2 more there for a total of 6. Now I see that my carbons and hydrogens are both balanced. The only thing that's unbalanced is the oxygens. And so if I have 2 oxygens on the left and 6 on the right, I simply need to add a 3 as a coefficient on the left side, and that gives me 6 oxygen atoms on the left. Just as I've always done with balanced equations, I want to go back at the end and check everything. I see 2 carbons on the left, 2 carbons on the right, 4 hydrogens on the left, 4 hydrogens on the right, 6 oxygens on the left, and 4 plus 2 oxygens on the right. So now I know I have a balanced chemical equation for the combustion of C2H4.